Hello guys, guess what? We're going to learn the classification of organic compounds. Oh yes, and this is our lesson 2, right? Oh yes. So in organic chemistry, I told you that we have a lot to cover. So how do you classify organic compounds very quickly? Now follow me very fast. In the classification of organic compounds, I like you not to forget is that organic compounds first, they are formed, right? When carbon combines with other elements. And then I gave you 5 exceptions in the first lesson, right, to the definition of organic chemistry. And don't forget is that organic compounds can be obtained either from nature, that means you can obtain them naturally, right, or you synthesize them in the laboratory. All those ones that we get from your living organisms or living things, those organic compounds that are derived from living things, whether from plants or from animals, all those ones are natural. But those ones that you get from inorganic sources that you want to synthesize in the laboratory, right? All those ones are the synthesized format, so they are not natural. Either you obtain them naturally or you synthesize them in the laboratory. Anyone, you can obtain your organic compounds from any of the two. And I'd like you not to forget is that organic compounds are classified into how many categories? 2 categories. Number 1 is called the hydrocarbons, and number 2 is the what? Non-hydrocarbons. So how many categories of organic compounds do we have? There are 2 of them, hydrocarbons and the what? Non-hydrocarbons. I know you'll not be asking, sir, which one is hydrocarbon? Which one is what? Non-hydrocarbon. Let's start with the first, hydrocarbons. Hold on a bit. The complete series of classes, right, as far as your syllabus is concerned regarding your Jamb And Waec, everything has been covered in details for you in the LearnLift app. And guess what? The sweet part is that you have access to your CBT, right? You have access to your video lessons. You have access to your notes. You have access to your past questions. Everything from the beginning to the end is directly in the LearnLift app for you. So all you have to do is just mark down to Play Store or App Store and download the LearnLift app where you follow all your classes from the beginning to the end. A quick one before we move. Let's get back to class. Enjoy. Yeah, so in hydrocarbons, what should I know? First, just know the definition with me. Take note that hydrocarbons are hydrides of carbon. I know you are shocked. You want to hear hydrocarbons are compounds that contain hydrogen and carbon only. Yes, they contain hydrogen and carbon only, but sometimes you may not even see that definition close by. So hydrides of carbon, hydrides of carbon, hydrides of what? Carbon, hydrocarbons. For example, your methane. Methane is your CH4. Is this not hydride of carbon? Yes. Right? Your benzene is C6H6. That's your benzene. Hydrides of carbon. Hydrides of carbon. What are they? They are the hydrocarbons. They contain carbon and hydrogen only, nothing else. Another important thing you must know is this. The main families of hydrocarbons, what are they? Come with me. What are the cocoa family, the main family of hydrocarbons? They include the following. Number 1, alkanes. They are main family of hydrocarbons. Because what you see in alkane is just carbon and hydrogen only. Alkanes, they are hydrocarbons. Another cardinal example are the alkynes. So your alkanes, they are hydrocarbons. In fact, we have things like your benzene. Benzene is hydrocarbon. And then we have things that include your what? Your naphthanes. Naphthanes, which are the cycloalkanes. All these guys are hydrocarbons. Give me, what do we have there? Your alkanes, your alkanes, your alkynes, your benzene, your naphthanes. Listen, you know, the problem about organic chemistry is that some people don't pay attention well. Naphthanes are not naphthalenes. They are different. Just learn this with me. Naphthanes are the what? Cycloalkanes. So aside cycloalkanes, we also have things like your what? Your cycloalkanes. They are still hydrocarbons. Cycloalkanes. In fact, we also have your cycloalkynes. All these guys are still what? Hydrocarbons. Alkanes, alkynes, benzene, naphthane, which are the cycloalkanes. Then the cycloalkanes, the cycloalkynes, all of them are what? Hydrocarbons. Does it make sense? You get this very fast with me. What about the other category? They are the non-hydrocarbons. Anything that contains more than carbon and hydrogen, you now have any other thing in addition. If you like, have only oxygen in addition, you are non-hydrocarbons. That's why we said that non-hydrocarbons, they contain elements that are other than carbon or hydrogen and what? Carbon. So aside carbon and hydrogen or hydrogen and carbon, they have other elements. Even if it's just sulfur that is there, non-hydrocarbon. If it is nitrogen, non-hydrocarbon, oxygen, phosphorus, halogen, metal. In answer, you have any other thing in addition to it. What are you? Non-hydrocarbon. So hydrocarbons are the hydrides of what? Carbon. That means they contain carbon and hydrogen what only. When you have any other thing in addition, who are you? Non-hydrocarbon. Does it make sense? If you get this very fast with me, please, let's start well now and dwell on hydrocarbons. So we're going to flow all through hydrocarbons first, then I'll come back and then show you some things under non-hydrocarbon. But first, under hydrocarbons, right, which will be our major fulcrum as we proceed in the classes, what should we know? First, understand this, that hydrocarbons, they are hydrides of your what? Your carbon. So they contain hydrogen and what? Carbon atoms only, right? And don't forget this, that traces of other elements may be present, but not that other elements are now adding to it, but those traces are coming as what? Impurities. So if you see traces of other elements, what are they standing as? Their impurities. And you must note that hydrocarbons can be categorized. Oh yes, either as saturated hydrocarbons or unsaturated hydrocarbons. Come with me from here. You keep hearing things like saturated hydrocarbon, non-saturated hydrocarbon, and you don't know the category to which they belong. Which hydrocarbons are saturated? Which ones are what? Unsaturated. Now, you must understand this, that saturated hydrocarbons, they contain single covalent bonds. Single covalent bonds. Come on. So a good example is your alkanes. Where I come. Like for example, when you hear alkanes, don't worry, as we move, I'll treat all of them. But when you hear alkanes have its own members. Inside alkanes, there are members. One of the members of alkane is called your methane. What is it called? Methane. What is it called? Methane. Now, what is the structure of methane? Methane is carbon to hydrogen, to what? Hydrogen here, to what? Hydrogen here, to what? Hydrogen here. If you watch, there's nothing like double bond. All three, they are single bonds. Another member is called your ethane. Ethane is another member. As you move, I'm going to give you first at least 100 members that you should know. In your ethane, it is carbon to carbon like this, to your hydrogen here, to your hydrogen here like this, to your hydrogen here like this, to your hydrogen, to your hydrogen, to your what? Hydrogen. We have not entered naming first, but just know this. What do you see in saturated hydrocarbon? This guy is saturated, this guy is saturated because they are under alkanes. They contain only single covalent bonds. All their bonds like this, all their bonds are single bonds. In fact, in organic chemistry for hydrocarbons, it's either you have single bond, or you have double bond, or you have triple bond. Anything that contains single bond only, what is it? Saturated hydrocarbon. So the opposite is now true. In your unsaturated hydrocarbon, what do they contain? They contain double or triple covalent bonds. A good example are the alkanes and then the what? Alkynes. So any compound that has double bond or what? Triple bond, is it saturated or unsaturated? It is what? Unsaturated. So if you have single bond, saturated. If you have double bond, unsaturated. Okay, you see a compound like this, they say carbon like this, to double bond to carbon, then they now put like hydrogen here, then hydrogen here, then they now put hydrogen here, then they now put hydrogen here. Is this compound saturated or it is unsaturated? That is what? An unsaturated hydrocarbon. Why? Double bond. If a compound now have carbon like this to triple bond to your carbon to hydrogen here, and then yes, now to hydrogen. Please, what type of compound is this? Is this saturated or unsaturated? Unsaturated. Just check. If you have single bond or true, saturated. If you have double or triple bond, unsaturated. Does it make sense? So alkanes, what are they? Saturated hydrocarbons. Alkanes, unsaturated hydrocarbons. Alkynes, unsaturated hydrocarbons. If you get that very fast with me. So when it comes to creating an account, right? This is the interface of the app that you can see. You can see create account and you can also see login. Now, what you do is this. As a new user, you don't have an account yet, so you don't need to go and log in. You go and create an account as a new user. Click on that create account button. Once you click on it, the next thing is put your phone number. Place in your phone number. You can see +234. Then put your phone number, whatever your phone number is. If you don't have phone, you can use your mommy's phone number and put it there, right? Or your daddy's phone number. Use it and then you can proceed and create the account. So let's go. So once you create the account, you have put in your phone number. What happened? put your name, your correct phone number, please. Put your name. If your name is John, what do you fill in there? John. And then your last name, Frank. Fill in John Frank. And what's your email address? Okay, if your email address is johnfrank3@gmail.com, you fill it there. And then your password, very important. You create your own password, 6 digits. You can use your phone number, the first 6 digits of your phone number, or the last 6 digits of your phone number. Or you can, okay, since your name is John Frank, you can say, okay, my password name is John, right? John 123. And then you go and repeat the same thing, confirm password. What will you type there? Your John what? 123. You can decide to view it to yes or and then see whether you are doing the same thing, whether what you are doing is correct, right? All you have to do is just click the I button there and then you view it. And then come to select education. You are preparing for Jamb or Waec. In select education, there are 4 plans there. University, that's for people that are in university. Probably 100 level, 200 level, right? Yes, their classes are also there. Secondary, for those in secondary school, primary. But for Jamb and Waec, click Waec Jamb Pursue TME, right? As the select education. Select level. You are not preparing for Pursue TME, you are preparing for Jamb and Waec, right? Okay, click on the what? Jamb and what? Waec. And then create your account. 2 seconds. Plus, you don't enter. It will load and then it will open for you. And it will tell you, welcome, John, right? Your classes are now what? Ready. What do? Start learning. Take note that in your hydrocarbons, right? Don't forget this. In your hydrocarbons generally, the carbon atom has 4 valence electrons. How many valence electrons? 4. So it is that 4 valence electrons that enables them to form 4 covalent bonds in a tetrahedral arrangement. Let me show you. Look at this very fast. If I have my methane is CH4, right? If methane is CH4, how do I draw it? It is carbon, right? That will now link to how many hydrogen? 4 hydrogen. Hydrogen here, hydrogen here, hydrogen here, like this. If you watch, all of these guys here, single bond, single bond, single bond, single bond, right? So how many valence electrons can your carbon accommodate to itself? 1 carbon atom can pull 4 valence electrons to itself. That's why they have 4 covalent bonds in what? Tetrahedral arrangements, especially in which of them? In your alkanes. This is for alkanes in particular. Are you getting it now? Okay, look at your, if we have something like your C2H6, like, right, we should draw it. What is it going to give you? You don't need to understand the naming first. Just follow me. Just understand the explanation. If I have carbon here, it is how many carbon? 2 carbon. Carbon, that's 2. How many hydrogen? 6. That means hydrogen here, hydrogen here, hydrogen here, and here is hydrogen. Here is to your hydrogen. Here is to what? Hydrogen. Every carbon must be bounded to 4 atoms. This is 1 carbon. How many atoms? 4. Here is 1, here is 2, here is 3, and here is 4. Now, look at this second carbon here. Every carbon was bounded by 4 atoms. This is 1, this is 2, this is 3, and then this is what? 4. Every carbon must be bounded by how many atoms? 4 atoms. Does it make sense? Well, let's proceed. And because every carbon must be bounded to 4 atoms, they form a property called what? Tetravalency. What is it called? Tetravalency. That means as a carbon, I am being bounded to 4 other atoms. Of course, that's what? Tetravalency. In other words, you can say carbon is what? Tetravalent. Does it make sense? You understand that very quickly with me. What are the sources of what? Hydrocarbons. Oh, yes. In the sources of hydrocarbons, I want you to note this very fast, that the major sources of hydrocarbons, they are your coal, petroleum, natural gas, 3 of them, and they form CPN. What is it called? CPN. What's your CPN? Your coal, your petroleum, natural gas. Again, coal, petroleum, natural gas. These are the main sources of hydrocarbon. What are the major sources of hydrocarbon? Your coal, your petroleum, and your natural gas. And you must note this, that they are called fossil fuels. So your coal, or your petroleum, or your natural gas, or what do we call them? We call them altogether your fossil fuel. Why? Because they are formed from the remains of plants and animals that have been buried under the ground, right? For millions of 40 years ago. So what are the sources of your hydrocarbons? What are they? They are the coal, the petroleum, and the natural gas, CPN. So your coal, petroleum, natural gas, together, what do we call them? They are called your fossil fuels. If you get that very fast with me, what are the types of hydrocarbons that we have? Well, let's go. Under the types of hydrocarbons, I want you to note this, that hydrocarbons, for example, organic compounds, we can divide them into hydrocarbons and non-hydrocarbons, right? And I told you that hydrocarbons are either saturated or unsaturated. Hydrocarbons themselves, they are divided into two types. What are the two types of hydrocarbons? Number one are the aliphatic hydrocarbons. Number two are the aromatic hydrocarbons. So your aliphatics are different from the aromatics. The question is, which of them are the aliphatics? Which of them are the aromatics? We're going to start, because you must see here, before you'll be able to attempt the JAMB questions very well, you must understand and know the foundation. That's what I'm trying to build with you, so that you understand this very quickly. Let's look at the first, aliphatic hydrocarbons. Aliphatic. Which hydrocarbons do we call aliphatic? First, understand this, that aliphatic hydrocarbons consist of chains of carbon atoms. What are they made up of? Chains of what? Carbon atoms. And those chains of carbon atoms, they may either be open chains or cyclic structures. So your aliphatic hydrocarbons, in fact, it's very okay to say that aliphatic hydrocarbons are broken into two. The ones that have open chains and the ones that don't have open chains, because those ones that don't have open chains will form cyclic structure. You will see that shortly. Please don't forget this, that aliphatic hydrocarbons do not contain benzene ring. So anything that makes you to contain benzene ring, you are already aromatic. Hydrocarbons are divided into two, right? Aliphatic and aromatic. Aliphatic hydrocarbons, they contain what? Chains of carbon atoms. And those chains of carbon atoms may either form open chains or your cyclic, which are the closed chains. Either the chains are open or they are closed. If they are closed, that's cyclic. Now, anything that has benzene ring in it, how does benzene look like? Your benzene is C6H6. And then this is how we draw your benzene. As we move, you're going to learn a lot. This is how your benzene is, like this. Anything that contains benzene ring is no longer what? Aliphatic hydrocarbon. You are now aromatic hydrocarbon. And don't forget this, that aliphatic hydrocarbons themselves, we said that they are divided into two categories. What are the two categories of aliphatic hydrocarbon? Number one, those that have open chain structure. Number one is this guy here, open chain. Number two is the one that have cyclic structure. Let's build on number one. Those that have open chain structures are called a cyclic compound. Whoa! The word A, if you see something like A, for example, asexual in biology, what does it mean? Absence of sexual reproduction. Asexual, absence of sexual, right? Oh yes. So a cyclic means absence of cyclic. Those guys that are not cyclic, that are open chains, right? What do we call them? They are called a cyclic compounds. And the second ones are those that are now the cyclic compounds. Those cyclic aliphatic compounds are called alicyclic. Don't go and mistake a cyclic and alicyclic. Now, first, if you watch, what is common there is cyclic. The first one that is acyclic means absence of the cyclic structure. That's why those ones that don't have that cyclic structure, what do we call them? They are called your open chain structures. If you have cyclic structure, that's how we call you ali. Ali means presence. Ali means what? Presence. A means absence. Alicyclic means the presence of the cyclic structure. Acyclic means absence of what? Cyclic structure. Does it make sense? You will see them now. Look at the first. The first is called your acyclic compounds. Acyclic compounds, are they closed chains or they are open chain? They are the open chain structure. And they are either straight chains or they are branched chains. Come with me. For example, a cardinal example is your ethane. How do we draw ethane? Ethane is carbon to carbon like this, right? To hydrogen like this. To hydrogen, and then here is hydrogen. Here is your what? Your hydrogen. And this, the condensed formula for it is your what? Your C2H6. This is called your what? Your ethane. The name of this compound is your ethane. So if this is my ethane, now the quick question is this: is ethane open chain or it is closed chain? Open chain. You can see the way it's looking. This guy is open chain. Does it make sense? And because it is open chain structure, what do we call it? It is acyclic. Another example is your ethane. Okay, what is ethane? Ethane is your carbon to double bond. Ethane is double bond. Ethane is single bond. Don't worry, I will teach you name it. Now, if I have this is to hydrogen here, this is to your hydrogen here, this is to your hydrogen here, this is to your what? Hydrogen here, right? And the name of this structure is your what? Your ethane. Ethane is C2H4. Don't worry yourself. As you move, you learn all those things quickly. Now, if ethane is C2H4, the question is this: my ethane here, is it closed chain or it is open chain? Open chain is what ethane is. Now, okay, but sir, you are confusing me. This guy here does not have double bond. It is single bond, not true. In the first one, that is your ethane. And because it is single bond, not true, it is your saturated acyclic compound. Does it make sense? Can I call it saturated acyclic aliphatic compound? Yes, you are still correct. Okay, what about this guy now that has double bond? It is what? Unsaturated acyclic aliphatic compound. Get out. Yes, that's how it is. And then we have your 2-methyl propane. These guys, this guy like this, and that you see, all of them are straight chains. The first two, they are straight chains. But you see, 2-methyl propane. Now follow me from here. Your 2-methyl, the third one, this is number 1, this is number 2. The third one is 2-methyl propane. How do I draw it? Your propane is carbon to carbon to carbon, right? Methyl, CH3 here. So to hydrogen here, to hydrogen here, to what? Hydrogen here. Here is to hydrogen, 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 and here is to what? Hydrogen. Don't worry, you learn these things with me. Now, this guy, because of this guy that is branching downwards, it is a branching. That's why I said that your acyclic compounds, they are the open chain structures. And because they are open chain structures, what are they? They are either straight chains or your what? Your branching. Your ethane and your ethane, both of them are what? Straight chain. But your 2-methyl propane, this guy is what? Branch chain. Does it make sense? Don't worry. Just what I want you to know here is this: your acyclic compounds are open chain structures, and they are either straight chains or what? Branch chains. That's all you should know first. If you get that very quickly with me, the next now we're now going to look into the ones that are cyclic. But before we go into the ones that are cyclic, I'd like you to answer these questions for me. Indicate whether saturated or unsaturated in the following. Are you ready? Yeah, let's go. Look at the first here. Ethane, we are to indicate whether it is saturated or unsaturated. How do we draw ethane? Ethane first, ethane is your C2H6. Draw it for me. Carbon to carbon. Here is to hydrogen, 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 here is to hydrogen. Now, from this guy, what can I see all true? All true, you have single bonds, all true, right? If you have single bonds, all true, you are saturated. If you have double or triple bond, you are what? Unsaturated. Because this guy has single bond, all true. What do we say? What do we say this guy is? It is your what? Your saturated hydrocarbon. Simple. You're out of there. Now that you have created your accounts, right? For you to start learning, what do you do? Okay, you can see that your use of English is there, mathematics is there, biology is there, physics is there, chemistry is there. Your classes are organized, they're all there for you, right? What do you do? Okay, I want to start learning biology. So click on the biology, immediately you click on it, living organisms, that's chapter 1, right? Oh yes, that's strictly to your JAMB syllabus. And what happened? Let's say, for example, you want to watch your class on cell and probably cell structure, right? What happens is that you click on it. Immediately you click on it, you see all the classes will display history of cell, types of cells, cell organelles, and all of that. Okay, sir, I want to watch history of cells. You click on the history of cell immediately. Hello, friends. Your class will start playing for you. It's easy and it will start playing for you easy and direct. And what happened? You can even choose to make it full screen. Right? Make it full screen. What happens? You are started learning and you are enjoying your classes. In fact, you may choose to say, okay, I want to download my classes. In fact, you can fast forward, you can take it backwards, you can pause, you can rewind, anyone you want to do. You can even say, oh, sir, I want to download my classes, right? Probably you use night sub just to click on download buttons. When you click on download button, you see the download. Before you know what will happen, the download will start loading. As it start loading, you can see it is moving. And then it's enter your phone. Are you getting it now? You can now go and start watching your downloaded classes. You can download as many classes as possible as you want to download. Now, you can even choose to say, okay, sir, that cell, the notes underneath it. It's the same thing for everything. I want to download my notes. All you have to do is click on the download for your notes. Before you know what is happening, it has entered your phone. You may choose to come to the notes, right? Under the characteristics of living things, let me open the notes and read the notes and go through the past questions. So you see, well organized and structured notes, direct to the points, focusing on your syllabus for you. There are past questions for you in abundance. You see, you have your past questions here. You can choose to say, okay, I want to zoom it in, right? And then the same thing for all subjects. And you are following. The answers are there. Number one answer is B. Why is the answer B? It is explained for you in details, every singular thing, and then you are following your classes. You are done with that. You come to the next. You see your notes, everything structured and organized to the core. In fact, at the end of the day, there is a blow kiss for you. You have done well. Get out, you too much. Everything is structured and organized for you in the app, right? And you can now choose to say, okay, sir, what about chemistry classes or physics classes? You can do same. Use of English, all of them, they are there. When you click on your chemistry classes, what happens? Separation of mixtures and purification. All of them are in line with your JAMB syllabus. Chemical combination, right? It just goes straight. You see, chapter 1 alone has 39 videos. 39, you sit yourself down, and you start learning. And you are following all of them one after the order. Does it make sense? Are you with me? When you want to access your download classes, all you have to do is just scroll down, right, on your home interface. Go to your access your download classes. Start now. You start. You see them, right? In fact, you may even choose to go and practice CBT, right, or past question. Let's say, for example, I go to my CBT, the one that has to do with my my biology. Then I want to take all the questions on that cell, probably your Waec cell or the JAMB question on it, right? Just to click on it. So you see, all the questions are there. There are 40 questions there for you already. All of them on that cell. What happened? Which of the following cell inclusion can destroy other cell organelles? Probably you now say, oh, some answer is lysosome. You choose it, you go to next like that. At the end of the day, you see your answer, see your corrections. All of these things are in the LearnLift app directly for you. Are you with me? So as far as your JAMB 2025 is concerned, my dear, you don't have an excuse whatsoever to have anything less than 300. Are you with me? All your classes are available for you. All you have to do, start learning now.
Download the LearnLift app now.
The next very fast is your propane. How do we drop propane? What is the formula for propane? Propane is C3H8. Sir, is there a way you are knowing these things? Yes, I will teach you all of this. Just be flowing first. Your propane is C3H8. It is carbon to carbon to carbon. That's C3. H8, hydrogen, hydrogen, hydrogen. Yes, your hydrogen. Yes, your hydrogen. Yes, your hydrogen. Yes, your hydrogen. And yes, your what? Your hydrogen. C3, H8. Count how many hydrogen. Yes, your 1, 2, 3, 4, 5, 6, 7, 8. Now, if you watch, is this single bond that I have all through? There is double bond. Single bond all through. So what is it? This guy is your what? Saturated hydrocarbon. If you have single bond all through, what are you? Saturated. Indicate this one fast for me. Ethene. Ethene is C2H4. That's your ethene. It is carbon to double bond to carbon. Ethene. And then yes to hydrogen, yes to hydrogen, yes to hydrogen, yes to hydrogen. Now, if I have this here, if you have single bond saturated, double bond unsaturated, triple bond unsaturated, this is double bond here now, double bond. So because there is double bond here, what is the entire compound? Unsaturated. Does it make sense? Indicate this one for me. Ethyne. Ethyne. Okay, this is your ethyne. Ethyne is your C2H2. That's your ethyne. It is your carbon to triple bond to carbon to hydrogen here. To what? Hydrogen here. And then you're kind of like asking, sir, how come it's not like this? Every carbon was bounded by 4 atoms. Yes, this is one carbon. 4 atoms. 1, 2, 3, and 4. Triple bond. Here is one carbon, 1, 2, 3, and here is what? The fourth one, balanced. So if you have triple bond, are you saturated or unsaturated? You are unsaturated. If you have single bond, only then are you saturated. Does it make sense? Okay, now that you get this very fast with me, the next we are going to look at, we have looked at everything about the acyclic, right? After acyclic compounds, the next is the what? Your cyclic aliphatic compounds. The ones that are cyclic aliphatic compounds, what do we call them? We call them alicyclic. Ali means presence of. Alicyclic, presence of that cycle. Are you getting it now? And don't forget this very quickly, that cyclic compounds are the closed ring structures. What are they? Closed ring structures. And they are formed when the terminal carbons, right, in your open chains, when they join. Oh, we said a good example is your cyclohexane. Come with me. In your hexane, what's the formula for hexane? Hexane is your C6H14. That's the formula for your hexane. Now, how do we draw hexane? It is carbon to carbon to carbon to carbon to carbon. 1, 2, 3, 4, 5. Here is your 6. Now, this is hydrogen here. Every other side should have hydrogen like this. You just draw them. You just fill everywhere like this. With what? Hydrogen. You just fill every other locations with hydrogen. Now, this guy that I've just drawn, that's your hexane. Hexane is not cyclohexane. In cyclohexane, look at it now. The terminal end like this, those terminal ends, right? It's like we are now joining them together. If you join them, their entire structure will change. Hexane is a cyclic compound, but your cyclohexane is your what? Your cyclic compound. Cyclohexane is cyclic. That's why the name, anything that starts with cyclo as the name is a cyclic compound. Let me show you very fast. Now, name all of these structures for me correctly. The first one we have to name is this. If you see this guy here, it has something like triangle, right? Cyclic. And because it is cyclic, here is one side, 2, 3. If you have 3 sides in organic chemistry, you are prop. So what's the name of this? It is called your cyclopropane. What is it called? Cyclopropane. Just understand. Just know it with me first. What is it called? Cyclopropane. That's the name. You're out of there. Name this other guy for me. How many sides do we have? Is somebody now going to say square? If you try and if I not you, it's not square. Here is your 1, here is your 2, here is your 3, here is your 4. If they like, they should draw rectangle there. Their name will still be the same as square. What is the name of the structure? It has 4 sides. 4 sides, they are butane. So what's the name? Cyclobutane. So the name of this guy is your cyclobutane. Please take note, I'm not teaching naming yet. We have not entered UPAC nomenclature of organic compounds. Name this structure for me. How many sides? Just tell me the number of sides. I'll give you the name. How many sides does it have? Here is your 1, here is your 2, here is your 3, here is your 4, here is your 5. If you have 5 sides, it is pent. What is it called? Pent. So what's the name? Thank you. The name is cyclopentane. Is the name cyclopentane. Name this guy for me very quickly. How many sides do we have here? It has 6 sides, correct? Here is your 1, here is your 2, here is your 3, here is your 4, here is your 5, and here is your 6. Since it has 6 sides, anything 6 is hex. So what's the name? Cyclohexane. Thank you. Cyclohexane. Anything that has 3 sides, what did I say? It is called prop. That's why we have cyclopropane. 4 side but, cyclopentane. 5 side pent, cyclopentane. 6 side hex, cyclohexane. Okay, name this last but not the least for me. If you watch, it now has double bond on 2 sides, right? What is it called? It is hex as well as 6 sides. The name now is your what? Your cyclohexadiene is the name. Hexadiene. Don't worry. What's the name? Hexadiene. As we get to naming, you will learn these things very well. You will know it to the core. But please, for the now, just be following me and understanding this part. If you get this very fast with me, guess what? What about aromatic compounds? I've given you everything about your aliphatic compounds. What is it? Aliphatic. We said that your hydrocarbons are divided into 2. Aliphatic, and the second one is your what? Your aromatic. Aliphatic are divided into 2. Acyclic and what? Cyclic. A cyclic are the open chain structures, which are either straight chains or branching. Your cyclic are the alicyclic, and it's different from your what? And you know that your acyclic, they are different from your what? Aromatic. Does it make sense? Now the question is, okay, under aromatic, what and what are they, and what should I know? Anything that has to do with benzene ring is aromatic. First, understand this, that aromatic hydrocarbons contain benzene ring. What do they contain? Benzene ring. So that benzene ring structure must be there for you to call it aromatic, or their structures must be derived from benzene. And don't forget this very quickly, that these compounds, they exhibit unique electronic configurations and chemical behavior as a result of your what? Aromaticity. So aromaticity is one of the character of aromatic hydrocarbons. So what is the major character of aromatic hydrocarbons? Aromaticity. And I want you to note this, that examples of aromatic compounds, what are they? Benzene is a cardinal example. Oh, how do we draw benzene? This structure is the structure for benzene. Either you draw it like this or you draw it like this. One of them is the old. This one is the old format of benzene. In fact, we don't draw it like that anymore because of a phenomenon called what? Resonance. When we get to benzene, you are going to learn all of these things. And then this is how we draw benzene. Then we place ring structure like circle inside of benzene currently. And then we also have what is called your toluene. Toluene. This is your toluene. Your toluene is your methyl benzene. Your methyl benzene is called your toluene. As you go, you're going to learn different structures of it. Auto, meta, para, and the rest of it all. So this guy here is your what? Your toluene. Aside toluene, we have what is called your naphthalene. It's different from naphthalene. Your naphthalene, this is the structure for naphthalene. It's just like you're carrying two benzene, drumming them together. But the only difference is there is no double bond. Now, one has 3 bonds inside. Like double bond, 3 inside. The other one has just 2. Look at it well and look at the structure. It is like this. This is how we draw it. Your naphthalene like this. You draw it this way, then double bond 3 inside one. The other one only has 2. Not that I come and add one here. If you come and add one here like this, you are wrong. Go ahead. So this structure is wrong. This is the correct structure for your what? Your naphthalene. Does it make sense? If you get this very quickly with me, bro, I'm super excited. Your benzene, your toluene, your naphthalene, all of them are what? Aromatic compounds. Oh, bro, please don't forget this very fast, that I told you that organic compounds generally, right? Sure, they are divided into 2. What are the 2 of them? Give me fast. Hydrocarbons and what? Non-hydrocarbons. If you are dwelling on hydrocarbons, I told you that hydrocarbons, there are 2 types of them, right? What are the 2 types? Your aliphatic, and then what? Aromatic. Under aliphatic, they are further divided into 2. What are the 2 types? Number 1 is called acyclic open chain, and the second one is called your what? Your cyclic or alicyclic. Now, under your acyclic, what are they? The commonest example are the 3 of them that you know: alkanes, alkynes, right? Alkanes, alkanes saturated, alkanes and alkynes unsaturated. That's under what? Acyclic. Ahead. Under the cyclic now, we now have things like your what? You now have your cycloalkanes, your cycloalkanes. In fact, even your cycloalkynes is also there. Your cycloalkynes is also there. Now, your cycloalkanes saturated, cycloalkynes unsaturated as well. Then you now come to your aromatic. Under aromatic, that's where you now have your benzene, your toluene, and so on and so forth. If you get this very fast, you have done well for yourself. Bro, I beg you, look at this very quickly with me. If they ask you that your hydrocarbons are divided into 4, for example, they ask you that hydrocarbons are divided into 4, you should list them. You should know that what you should be looking out for are things like your alkanes, alkynes, probably not check like your cycloalkanes, right? Because all of them like that, they are under your what? Your aliphatic. And then you now have your aromatic are your benzene, because a past question. Oh, answer this question for me. Jamb 1988 question 45. If you fail it, I will not be happy with you. The question all the way says the 4 classes of hydrocarbons are, what are the 4 of them? I gave you only 2, but they're asking for 4 here. Ethane, ethene, benzene. Come with me first. Your benzene is aromatic compound, so I cannot go with that. Your ethane is under alkane. ethane is under alkane, ethane is under alkane, ethane is under alkyne, so that guy cannot even be it. Option B says your alkane, yes, alkanes, alkynes. You know, alkanes, alkynes, where are they under? Aliphatic. Inside the aliphatic cell, inside the aliphatic cell, which part of aliphatic are they? Are they under a cyclic or cyclic? They are under a cyclic. Alkanes, alkynes, all of them are under aliphatic. Then we now have aromatic. So I can say your hydrocarbons are divided into aliphatic, which are the alkanes, alkynes, and then aromatic. You are correct. So this guy is making a whole hell of sense. Option C says your alkanes, alkynes, benzene. Benzene is an aromatic compound. So instead of me to choose option C, I'd rather go for B. So C cannot be the answer because of benzene is what? Aromatic. Look at option D. Option D says methane. Methane is an alkane, so I can't even go for methane. Ethane, propane, butane, all of them are under alkane. So option D cannot be the answer. What is the answer? Option B is our correct answer. Easy, simple and direct. Do you understand this? If you get it very quickly, guess what, bro? I'll see you in the next class. Please go to my notes. There are a lot of questions in the notes, but please, in that next class, what are we going to look at? We're going to look at homolog, just what series. For the now, bro, I'll see you in the next class. Go to my notes, run through the past questions there, practice CBT, and tell a friend about the what Learn Lift app. For the now, peace out. I'll see you in that homolog series. Bye-bye. Hope you've enjoyed this class. Guess what? To follow up for more classes, just download the Learn Lift app, whether on Play Store or App Store, and then follow up your classes. You must do extremely well. I'll see you in class. Bye-bye.